In this video, I'm going to show you how to draw an XY scatter plot using some data that I've already typed in over here. And I'm going to put the graph in here. I'm going to add a trend line and a trend line equation to it and display the R-squared value. Then I am going to use the data analysis tool pack to generate a regression report. All right, first thing I want to do is select the XY data that I want to make a graph out of. These need to really be in adjacent columns like this. I'm going to go up to the Insert ribbon, and I'm going to go over to Charts, and I'm going to choose XY Scatter. So I'm going to choose this one right here. I'm not going to choose the one with connecting the lines because I'm going to draw a trend line on this in a minute. I want the layout to have a chart title and axis labels, so I go over to Quick Layout here, and I choose the first quick layout that I see. It gives me what I want. This data happens to be for a Beer's law plot for vanillin in 0.1 molar NaOH. So that's my title. And here I am going to put the concentration of the vanillin. And the units are milligrams per liter. And on the y-axis, I am going to put the absorbance at 347 nanometers. That has no units. And notice that it's already put my data in there. I only have one thing on here right now. I don't really need the legend, so I could delete that and give myself a little more room. I am going to now fit a trend line onto this. I'm going to click on the points. I'm going to left click on that. Notice that they all light up. Then I'm going to right click on it to see what I can do with what I just selected. One of the options I'm given is to add a trend line. So I'm going to choose that. Now I am going to add a fit equation, y equals mx plus b. I can display that on the chart by going over here and checking that box. And I also want to see the R-squared statistic. This gives you the fraction of variation in the data that your line is explaining. All right, so there, my graph is pretty much done. It looks like it's a pretty good line. If R-squared was 1, all of the points would be exactly along the line. And I'm seeing the slope and the intercept there. I'm going to take this and I can drag it around anywhere I want. I want to move it into this little yellow square up here. And there, I'm done with my graph. And now I want to generate a regression report for this data. So I am going to go up to, let me see. I need to get back to the data ribbon. So I go up here and I find data. And over here under analyze, I should see this item data analysis. Now, if you don't see that on your copy of Excel, what you can do is go over to the file menu and you can select options down here. And if you go down here to add-ins, it'll show you add-ins that you can add. Now I have this analysis tool pack. This is the one that I really need to do the job of putting a regression report in here. And I can scroll for that down here. And when I check that, when I add an add-in and check it, it will now appear on the ribbon, on the right end of the ribbon. Okay, so if you don't have that, you're going to have to add it in here on this screen. Okay, but I already have it. So I'm going to click Data Analysis. And I am going to come over here to look for a regression. There it is in this long list. So I'm going to say, okay, I want to do a regression. It wants me to put the Y range in here. So I'm going to click on this button. go over here on my Y values. I select them, I drag the mouse over them. To get the X range, I am going to go over here and I'm going to put the mouse button down and drag across the X values. And I've got those filled in. Now, I want to go ahead and check confidence intervals. I want it to show me confidence intervals on the slope and the intercept. I want to fit the whole regression report down in this area right here. So I'm going to say select an output range. And then I'm going to go down here and smear this just generally over the area where I want the regression report to appear. And I'm going to check all these boxes just to see what they do. This gives you residuals. Those are the differences between the predicted and the actual Y values. Standardized residuals, these are divided by the standard error of the estimate. And a residuals plot, and also a line fit plot. Now, I don't really need this last one because I already have a line fit plot here. That could have generated it automatically for me, and then I could edit that. So I think I'll uncheck that one because I already have done it by hand here. And I don't need a normal probability plot. I'm going to say OK and see what happens. This is going to overwrite existing data, so it's going to erase the stuff I have written down here. Okay, so there's my residuals plot over here. And I can move that around if I click on it. I can move it anywhere I want. But that's the residuals plot. I can edit that too any way that I want. Let's take a look at the important pieces here. If you're looking at the residuals plot, you want to examine this for various things. You want to make sure that more of the residuals are close to zero than are not. You also want to make sure that you're getting kind of a random pattern here. That's going to indicate generally a good fit. The number on the y-axis here should generally reflect your uncertainty in measuring these y values. Now, what do I mean by that? We can look at some of these statistics and see what they mean. Here is the r-squared value. This would be 0 if you had completely random data. That is, your line explained absolutely none of the variation in the data. You'd have a 1 if all of your data was exactly on the line. Here, they're close, but they're not quite on there. The other important thing here is the standard error. This is the S sub y that you see in formulas. So that's called a number of different things. It's called the standard error of the estimate. It's also called the standard error of the regression. And generally, this is telling you what the standard deviation of the residuals is going to be. The standard error of the residuals is going to be around 0 right here. So it's telling you how much scatter you've got here, and we can kind of see that that kind of corresponds to what we're seeing over here on the residuals plot. All right, it tells you the number of observations you have here. That's the n, so that's important. How about if I just kind of highlight these important things to look at as we go along? Okay, so that's the r-squared value that you're going to use. Now, in this line down here, the only thing we really want to look at if we're not doing hypothesis testing with our regression is the significance F. Now, this compares your model, the line that we drew, with a model that has no parameters. In other words, it's giving you the probability that your model explains none of the variation of the data. Now, this number here, this significance F, should always be less than 0.05. And here it's much less, so this is a good model. So you always want to look at that. This is a way to assess how good your fit is going to be. So look at that. Now, the intercept and the slope are here. The x variable 1 is actually the slope that we have. And we can see that that corresponds to the slope we got up here, but it's not rounded off. It's not rounded off as much. The slope is 0.1668 up here, and it's 0.166796 down here. And we can see the intercept is 0.0016 here, and it's 0.001612 down here. So there's your slope and your intercept. You want to use those. Now this next thing is the standard error in those. Standard error in the intercept and standard error in the slope. Those are kind of important. This t-statistic is the t-statistic for a t-test that is testing the hypothesis that, in fact, your intercept is just due to random error. And if I go over here and look at this, this is a little bit more telling. This p-value tells me the probability that I would be wrong in rejecting that hypothesis. That is, it's the probability generally that the intercept is in fact 0. I have an 84.9% chance that the intercept on this graph is actually 0. Not surprising because this is a Beer's law plot and the intercept is supposed to be 0 for this. All right, but there's a very small probability that the slope is in fact 0. So that also is what I expect to see. So those are good to look at. Now it gives you the confidence intervals here. It gives you the lower and the upper bounds on the confidence interval on the intercept in this row. And it gives you the upper and lower bounds on the 95% confidence interval on the slope in those two values. So those are important to look at as well. Now, if I go down a little bit, I'm going to see the residuals output. This is telling me the residuals, the distance between the predicted y and the actual y. And I notice that these are bouncing up and down. I got some positives, I got some negatives, I got more that are close to 0 than are far away. The standardized residuals, the standard residuals, divide these by the standard error up here, the standard error of the estimate. So you look at these, and if you see anything that's bigger than 3 or less than -3, these are possible outliers, very probably outliers. We've got nothing like that in here, so none of these points can really be considered an outlier. All right, that's about it. You have your regression report here, and you have how to pull information out of the regression report.